Good morning students. Today we are going to solve a problem regarding finite element method. And this is our question. A thin steel plate of uniform thickness 25 mm is subjected to a point load of 500 Newton at mid depth as shown. The plate is also subjected to self weight. If Young's modulus E equal to 2 into 10 power 5 Newton per millimeter square and unit weight density 0.8 into 10 power minus 4 Newton per millimeter cube, calculate displacement at each node and stress in each element. So we are given with a self-hanging element, self-hanging bar with two elements E1 and E2. And since it is self-hanging, here there will be U1, here there will be U2, and here there will be U3, and it is hanging here, so there will not be any U1, there will not be any displacement in U1, and here there is U2 in here and U3 in here, and this is the point load. It is mentioned that the plate is also subjected to there's a point load of 500 Newton at mid depth, and the point load is 500 Newton, and the length of first element is 200 mm and the second element is 120 mm, and the breadth is same. So here we are given with thickness 25 millimeter. So area of element 1 will be 200 into that thickness, 200 into 25, which is equal to 5000 millimeter square. We can consider as A1. And similarly, area of element 2, E2, element 2 is 120 into 25, which is equal to 3000 millimeter square. This is A2. And we have point load P, Young's modulus E, and unit weight density. And we know that the force F equal to rho AL by 2 into matrix 1 1. Here for element 1, we will have F1 in here and F2 in here. So we have two force factors in element 1 and two displacement factor U1 in here and U2 in here. So F1 F2 equal to rho A1 L1 by 2 1 1. Here the self weight of this entire element is given as 0.8 into 10 power minus 4 Newton per millimeter cube. So we are substituting the values into this respective equation. So I will get it as 0.8 into 10 power minus 4 into 5000. We have already found in here into 100 divided by 2 1 1. And while we are solving it, we will get the matrix as F1 F2 equal to 20 20. Similarly, we are finding it for E2, that is element 2. In element 2, we will have the force vector in here and here, that is F2 and F3. Similarly, you will have displacement vectors in here, U2 and U3. So F2 F3 equal to rho A2 L2 by 2 1 1. And we know that we have already find this A2. So area of E2 equal to 120 into 25, which is equal to 3000 millimeter square. We are substituting the values. So 0.8 into 10 power minus 4 into 3000 into length L2 100 divided by 2 1 1. While solving that, we will get it as 12 12. Now we are combining F1 F2 20 20 and F2 F3 12 12. We have a common F2 in both these sections. So what we are doing is, while combining, there's one F1, we are writing is as 20, and we have two F2 20 and here 12. So 20 plus 12, and here one F3 only 12. So we will get it as 20 30 12. But we know that there is a point load of 500 Newton at mid depth, point load. That is, this should also included for F2. So while including the point load, we want to add 32 plus 500, which is equal to 532. And thus we will get global force factor. Why we are doing these steps means, I already mentioned you, the plate is also subjected to self weight. So there is a chance for elongation. Subjected to self weight, there is a chance for elongation, and we are finding that also, how much force is applied by the gravity due to self weight. So that is why we are going through these steps to get global force factor. And we know that F equal to, force factor F equal to AE by L, 1 minus 1 minus 1 1 into displacement U. So similar steps as you guys do on the previous assignment. For E1, F1 F2 equal to A1 E by L1, 1 minus 1 minus 1 1 U1 U2. I already mentioned you, for element 1 U1 will be here and U2 will be here, and for element 2 U2 will be here, U3 will be here. And we are all again applying the values. So F1 F2 equal to A1, we know 5000 into 2 into 10 power 5 by 100, 1 minus 1 minus 1 1 U1 U2. And here we will get the value as 1 into 10 power 7, and I am taking 110 into the inside of this matrix. So F1 F2 1 into 10 power 6, 10 minus 10 minus 10 10 U1 U2. And similarly for E2 also we are substituting the values, and we will get F2 F3 equal to 3000 into 2 into 10 power 5 by 100, 1 minus 1 minus 1 1 U2 U3. And here we will get the value as 6 into 10 power 6, 1 minus 1 minus 1 1 U2 U3, and I am taking the 6 inside. We are doing this step to make a common term, 1 into 10 power 6, 1 into 10 power 6. Actually we are doing this for making our calculation in an easy manner. And now we are combining these both. So you already know the steps. I have already mentioned this in the derivation. So it will come as F1 F2 F3, common term 1 into 10 power 6, 10 minus 10 0. A1 is here, A1 is here, A12 is here, A13 is not there. That is why it is becoming as 0. A21 is here, A22 is here. So A21 minus 10, A22, we have 2 A22 in here. Here this is also A22. So we are adding 10 and 6 to get 16. And it goes on like that. And we know that since it is self weight, so since it is hanged and it is sealed in here, so U1 will be 0. So we are removing the first row and first column. Since U1 is 0, we are removing first row and first column. This is for easy to solve the problems. So while removing that, we are removing F1 also. Since we are removing first row and first column of right hand side and left hand side, we will get it as 532 by 12 equal to 1 into 10 power 6, 16 minus 6 minus 6 6. We are removing first row, first column and first row. So we will get the other terms, this and this, U2 U3, and we are multiplying 8. We know that F2 equal to 16 into U2 minus 6 into U3 into 1 into 10 power 6, and 12 equal to minus 6 into U2 plus 6 into U3. And now we are combining these equations. We are adding this equation. While adding this equation, we can remove this U3 term, and we will get only U2 term. That is 544 equal to 10 into 10 power 6 U2. From here you will get the value of U2. That is U2 equal to 5.44 into 10 power minus 5 mm. And we are substituting this value in this U2. So while solving that, you will get the value of U3 equal to 5.64 into 10 power minus 5 mm. Now we have find out displacement at each node. So we have find out U2 and U3, and U1 is equal to 0. And now we want to find stress in each element. And to find, we know that stress equal to So we know the relation between stress and strain. Stress by strain equal to Young's modulus. We are using that relation here. Stress equal to E into du by dx. And E for first element, sigma 1, stress 1 equal to E into, here you have u1 and u2. So dy taking du, u2 minus u1. u2 minus u1 by L. And since u1 is 0, we are while substituting 2 into 10 power 5 u2's value that we have already gotten here divided by 100. So sigma 1 equal to 0.1088 Newton per millimeter square, and sigma 2 equal to 2 into 10 power 5 u3 minus u2 by L. By substituting the value, we will get it as 4 into 10 power minus 3 Newton per millimeter square. If you are having any doubt, WhatsApp me or mail me. Thank you.